Hey, what's going on, guys? KIM-1 here. In this video, I'd like to present an update on my modification of the KIM-1 emulator, which is the emulator of legendary KIM-1 computer provided by Oscar Vermeulen. So the changes I've made is the custom hardware I'm using here. So I'm using the LCD shield instead of the 7-segment LEDs, and I have a custom keypad here as well. And what I've changed in regards to the display of the main program running on this emulator, the KIM monitor. So now we can explicitly see that the leftmost 4 digits are the address. These 2 digits represent the data, the particular address, and also we have the mode. So either the addressing mode, the mode in the in the address or the data, or currently it indicates that we have stopped the execution of the program that I was running just right a moment ago. And if I run the program, it would be represented here as well. So we'll see all of those things. So let's say here I go to the addressing mode, and now I can input addresses, whatever, and let's say let's drop back to 0000, and here I go to data mode, and I can input some addresses here as well. But this is not the most significant thing I wanted to share with you guys, and what is really interesting is that unlike the original KIM-1, I've added a pool of addresses being responsible for outputting characters to the LCD screen. So from now on, this machine actually supports things like outputting the character to the LCD screen at the given position if needed to clear the LCD screen, to scroll the data on the LCD screen left and right, and even define the user-defined characters. So in this video, I'll demonstrate all of these features I've implemented today, basically. So let's walk through them step by step and see how they work. Right, so I'm going to be writing in 6502 machine codes, and I'm currently looking at the screen on my laptop where I have those codes. I will be trying to comment through what am I doing, basically. But again, like so some tutorials on how to code in 6502 machine codes are gonna like upcoming tutorials, so gonna be available on this channel soon, I hope. And I would be using the serial monitor to present that in a more user-friendly way, I would say. So you could have see like both the input and the 6502 opcodes and all the stuff that is needed for learning this sort of a thing. But for now, I just really want to focus on the real hardware, so there won't be that much of explanations. I just want to concentrate on the demonstration. So the very first program that we will write is the program to clear the LCD screen. And I'm using the hexadecimal address D014 in order to do that. So the addresses are inspired by the Apple I. So in Apple I, we have D012 to output the character to screen, D011 to read the character from keyboard, if I'm not mistaken, and 13 is not used, but it shouldn't be touched, basically. And starting from the address D014, we can actually do whatever we want, and hence this emulator just intercepts the calls to if we're trying to write to the memory that is not in the RAM, basically. So it's not going to be writing to the actual physical memory location. It's not possible for this hardware to release. But anyway, it mimics what we want to do, and this mimics what could have been possible if this was a real machine. So we can, if we just store whatever value to the memory address D014, this would result in clearing the LCD screen. So let's have a look how it works. So I want to go to the addressing mode. So 0000 is the address I want to have, and the opcode for STA instruction. Well, I could have used STX or STY, but I'm going to be using STA. The only thing matters here is the address, and we don't really care what exactly in the A register currently. We just need to fire the address, and that's how it works. So 8D is, so 0, 1, 2, 3, 4, 5, 6, 7, 8 D. Okay, sorry. Now we need to go to the data mode, actually. So I'm going to the data mode, and 8D, right? So this is the opcode for STA, and then in the little endian order, I need to enter the address. So 14 first goes 14, and then goes D0 like this. And then just to make this program loop forever, I want to say 20, which stands for jump, and 20 to address 0003. Again, like in little endian byte order, this is going to be 0, 0, 1, 2, 3, and 00, and then the next 00 is going to be a break. Okay, so going back to addressing mode and go into 0000. So AD 14D0 20 03 00, and then break. So far so good. So going back, and yeah, by the way, when I now click run, you just notice that here the mode would be turned to, oh, actually it just just cleared the screen, so probably won't be able to see that. But anyway, let's have a look. So you see, like, we just cleared the LCD screen. Well, nothing special so far, but I don't know, guys, how about you? But for me personally, this is a bit of a magic, even though I did this on my own, but still. And now, what is even more cool, if I just click the stop button, we just going back to the hex monitor, and whatever we had on the screen before that gets restored, and actually it's now shows the address where it dropped. All right, so this was clearing the LCD screen, and the next thing, we can also show or hide the blinking cursor. Pretty useless thing, but just as a proof of concept, I want to demonstrate that as well. Just hold on a second, I need to check up my notes. So to make it blink, okay, so for instance, if I go to addressing modes to 0, oops, sorry, nope, no, not like this. Go into addressing mode, 00, no, stop, addressing mode 0000, right? So this first 3 byte clear the screen, and then starting from this byte, so in order to make it work, I need to put the value of 1 to the address of D014 to enable the blinking cursor wherever position it is currently at. And for if I want to disable it, I need to put the value of 0 to D014. All right, so I'm gonna say, so go into the data mode, and A9, this stands for LDA, so I want to load the immediate data to the A register, and the data is 01, right? Just hold on a sec. Yeah, I just found a typo in my readme file. Okay, anyway, so this should be, the data should be 01. All right, and then again, like, just to loop forever, I can just say 20, and this was address 5, so 0500. Oh, what have I done? Okay, no panic. Going back to addressing modes, it should already be just fine, basically. So let's have a look. So we have okay, STA to D014, then oh, this, yeah, A9 is LDA, then the value of 1. Yeah, nope. And here, yeah, we need to go back to data mode, and actually STA to D014, yeah, to D014. So go into the data mode, so 14, no, STA, sorry guys, sorry. I need to say AD, this is the, sorry, not AD, AD, this is the opcode for STA, and then next, then 14, oh, horribly wrong. Yeah, I really need to get used to this. Need to get used to this sort of thing. So let's start from scratch. Okay, AD 14. Oh, hold on a sec. Did I just Yeah, hold on a sec, guys. I just really need to reference my source code because my README file did a bad favor to me. So I've just realized that, yeah, so just didn't work properly. Toggle blinking cursor is actually D015. Yeah, so just I just found a typo in my README. Okay, anyway, by the time we would be watching this, hopefully it would have been fixed. So this first just clears the screen, which is correct. Then A901. So now 1 is in the A register. What the heck is this? Nope. So we go into here. So this should be 8D. Next. Now 15. So 1, 5. Next, and nope, D0. Okay, so this fires the blinking cursor. So far so good. Okay, and then we take this infinite loop, so 20 to the address of 8. Next, 0, 8, 0, 0, and the break here. Okay, so let's get back to the data mode, sorry, to the address mode. 0, 0, 0, 0, and I just hold my breath, and if I did everything properly, it now should clear the screen and show the blinking cursor. Okay, it doesn't show the blinking cursor, so let's debug. Yeah. Yeah, this is how the program in 6582 assembly actually looks like. 0, 0, 0, 0. Okay, AD14, D0, A9, 0, 1. Or maybe I want to just hold on a sec. I need to make sure. So blink. Yeah, maybe 0, 0. Yeah, probably just, so here. Right. And 0, 0. And back to address. And 0, 0, 0, 0. Okay, still doesn't work. Okay. 0, 0, 0, 0. Okay. So clear screen works well. So to A register, I'm loading either 0, 1 or 0, 0. Okay, then AD. Yeah, I should prepare better for this. STAD 015. I swear it did work actually. Oh, 14. This should be 15. This one should be 15. So data and 1, 1, 5. And going back to addressing modes. D0, alright. Yeah, now this should be. Now, I don't remember, again, like 0, 0, 0, 1 to actually make a blink. Apparently, still need to change to 0, 1, but yeah, now at least. Well, at the very least, you see how this KIM-1 user experience looks like, even though it's not a real KIM, but still, it's pretty similar, I believe. So here, let's try to use 0, 1. Yeah, and all this stuff is, bear in mind the fact that I'm the author of this extension. Yeah, this is fun. Okay, 0, 0. Oh, no, don't go 0, 0, 0, 0. Yeah, now let's try. Okay, guys, so here is the blinking cursor. Can you believe this? So this looks really nice, right? So yeah, this was the blinking cursor. So far, so good. Okay, yeah, I'm really happy now. So let's drop back to the address of 0, 0, 0, 0. Then we skip the first 3 bytes, and starting from here, we'll now write a program to output a character to Uh, well, actually, probably we can already enable the. Now let's start by outputting the single character. So if I just say A9 and then the next, so let's say we want to output the letter A. So if I say go to data and 61 and next, and here let's say I want to jump forever, so 2 0 and here 0 5 and here 0 0 and here 0 0 to break, and going back to addressing mode 0 0 0 0, and now it should print the small a letter in this position where the cursor would be put there. Yeah, and by the way, you see, like, as far as I didn't disable the cursor, which is a bad thing, really. It still blinks wherever the cursor is. It's a little bit of a downside, so you always need to take care of that, basically. But anyway, let's try to run the program and see if it works. Yeah, so probably I just forgot to fire this to the memory address. Okay, so stop. Yeah, this blinking cursor now starts getting a little bit annoying. Okay, maybe I just start the program from scratch. It's be just a better idea. So, yeah, I will start by clearing the screen again. I'm sorry, guys, but yeah, so a bit of a downside. But anyway, so go into the data mode and 8D. Nope. 8D. Next, 14D0, 14, and then D0, D0, and then A9, and then 61. So loading a character to the A register, and then 8D to fire STA. So 8D, nope, 8D, and to 15, right? No, to 12, sorry, to 12, this time to 12. So 1, 2, and D, nope, D0. And next, I want to say 20 to address 8. So 0 8 0 0, and next 0 0 is break. Going back to addressing mode 0 0 0 0, and here we go. We got our magnificent A character being printed where the cursor is after clearing the screen cursor is here. And if we do our blinking cursor as well, it would be blinking here, but again, it just takes ages to input that. So I hope this is just good enough. All right. Okay, so now let's drop back. So address mode 0 0 0 0. Skip the first 3 bytes, and then now the next thing I want to do, so I'm going to be writing the memory here. So I want to specify the custom location for my cursor. Let me find the reference that I've provided for that. Cursor at position. So address 16. I just really need to verify this in my sources. Yeah, custom position 16. Yeah, should be the case. And here for a custom position, so I need to load into the X register. I need to load the column I want to print the character to, and into the Y register I need to load the row I want to put my cursor to. So let's start by loading, for instance, the X register. So here I need to go to the data mode, and I say A2, and this is LDX. This is the code for LDX, and the value here, let's say 0, 3. So this means that we are right into column number 3. Then the row, so now A0, and I want, let's say 4, right? Let's say 0, 4. So, oh, what have I done? No, it's, no, hold on a sec, guys. 0, 1. We only have 2 rows on the LCD screen. So it now should print the character on the second row on 0, 1, 2, 3. So here it should print the character. Well, I just need to input a few more bytes for that. So first, we need to fire the address to set up the cursor, and the address is 16, so I need to say 8D, 8D, right, and 16, right, so 16 D0. And next, we actually need to print the character again, so A9, and the character is 61, the A character, for instance, so 61, and then 8D, 8D, 12, and D0, and then 20 to address F, 0F, 00, and then the break. Okay, now hold my breath and go into data mode. And let's have a look. And oh my god, can you believe this, guys? So I just, what I did so far, so I did specify the location of row 1 and like 0, 1 and 0, 1, 2, 3. So in X register we're holding the column, and Y register we're holding the row, and we can just put the character to these kind of coordinates. We have the A letter. Okay, so far so good. So what else do I have here? Let's now have a look at scrolling the display left and right, which is quite pretty trivial. And then at the very end, we'll create a user-defined character, and we'll create a little sprite there. Okay, so I just reset my KIM-1 emulator. And so what I need to do here, so to A register, I need to enter either 0 to scroll right or 1 to scroll left, and then fire this to address D018. So go into the data mode, A9. So to A register, we're loading the instant value of 01. Okay, and then 8D, and fire the address D018. So first goes 18, then goes D0, okay, and then goes infinite loop, right, to address 5, 0, 5, 0, 0, and break, okay, 0, 0, 0, 0, and you see, guys, it has just shifted the content of whatever we have in display, just got shifted one step to the left. So actually, if I do this one more time, so go into 0, 0, 0, 0, and fire it again. Nope, stop. 0, 0, 0, 0, and run. See, like, now it just goes one more step to the left. Okay, so now to make it drop back, so stop, address 0, 0, 0, 0. Now if we change this to 0, 0, and 0, 0, and address, and 0, 0, 0, 0, and run, it goes back. All right, so going back to address, nope, stop, address 0000 and run, and we've just restored the position of the content of our LCD screen. So yeah, this might be used in order to scroll the data along the LCD screen, which is the hardware scroll that is enabled in this like LCD screens. Okay guys, so far so good. Now let's go for the ultimate demonstration of how to create a user-defined character. So we'll start. So this kind of LCD display allows us to create 5 by 8 bytes, 5 by 8 bits bitmap, and then create a character, and then to bring this character back to the LCD screen. So we'll now write the program to do that. Okay, so this is gonna be tough, but anyway, so I've already prepared a sprite. So if you've seen my Chrome Dino game running on CMK computer, which was the preceding one to this sort of a thing, then you remember like just like in Chrome browser, the Dino was jumping over the cactuses. Okay, running to where he was going to. So yeah, here I have 1, 2, 3, 4, 5, 6, 8 bytes. So first, I just want to input the bytes, and the bits in those bytes actually do represent how the Dino should appear. And I'm not going to be covering that many details how exactly this works. As you on this, like the real hardware demonstration doesn't make it that easy to explain. So I would rather instead just go in for demonstration. So start from the 0000, go into the data mode, and here are the bytes. So 0707. Okay, then 05. 05, then 07, okay, then 16, 16, then 1F, 1F, and next, then 1E, 1E, then 0E, all right, and 04 finally, 04. Okay, so here are the bytes for our Dino, and now we'll start entering the program, and bear in mind that we'll start executing our program from address 0008, so we need not to forget this address. So 0008 is the starting address for an execution. Yeah, now let me just go back to my cheat sheet. All this stuff is available on my GitHub, so yeah. All right, so create custom characters. So the X register should be containing the value of the index of the custom characters, so that it might be from 0 to 7. So this LCD display assumes up to 8 user-defined characters, and then the Y register should be pointing to the very first byte in the memory. So literally, I need to initialize both of the bytes, assuming the current layout of this custom character bytes to 0. So A200 and A000. So I need to say A2 it should be equal to 00, and then A0 also should be equal to 00. And now to create a user-defined character, I need to fire the address D017. All right, so 8D STA instruction, so 8D D017, right? So 17 1 17 D0. Okay, so now we've fired a new character, and then to print this to the screen, it's a bit of a downside that we actually need to clear the screen as well. So let's actually clear the screen first, because otherwise it would print the character, but it will leave the content on the screen. So to clear the screen, 8D, so 8D 14 D0. Okay, and now to A register, A9, we want to load the value of 0, 0, and this is the index. This is the index of our custom character. And then next, we just use the casual printing the character. So 8D, STA, so 8D to D012, so 12 D and 0, right? And infinite loop after, so 2, 0, address 17, 17, 0, 0, and then the break. Okay, going back to address mode. Oh my god, this is gonna be working. So now not to the 0, 0, 0, 0, but to the 0, 0, 0, 8, where the first byte of our program starts. And I hold my breath, guys. If I did everything properly, it now should draw a tiny dino here. Tiny little dinosaur. Let's have a look. Oh my god, can you believe this? This is a tiny little dino here. This is the custom character, custom user-defined character that we've just defined by the first 8 bytes from addresses 0000 to 0007, including that one, the last one, right? Okay, guys, so I think that's it from my side. So there are gonna be much more tutorials on coding in 652 machine codes on KIM-1, and I'm gonna be using the luxury serial terminal mode, and there we would be able to see both the 652 opcodes on one part of the screen, because I would be able just to record the desktop of my laptop. Just the screen on my laptop, that's way more easier and faster, because now I'm just standing on top of the camera, and just it's really distracting to see what the camera shows and the real device. It's really distracting. I'm sorry for this video taking a bit too long, but I really wanted to share how this KIM-1 user experience actually looks and feels like. And I don't know if anyone actually did this LCD expansion for KIM-1. I don't believe I'm the first guy who did this, but anyway, I think this is really cool thing to consider. So please let me know in the commentaries what do you think about this kind of extension. And again, like obviously on GitHub, you can download the project source code and the instructions on how to build this kind of device on your own. So all you need is LCD Shield, 4x4 keys keypad, and whatever Arduino of your choice. That's it from my side, guys. Thanks for watching. Until the next time, and take care.